All right, hopefully only 2 videos on power rule. We're going to first go over some basics, looking at some review problems. You guys are going to shoot me on this one, but I'm going to tell you it'll come up, and then I'll go, I told you so. All right, number line. Numbers decrease as you move to the left. So 2 bigger than 1, bigger than 0. -1 is bigger than -2, and -2 is bigger than -3. Please keep this in mind. Again, it'll come out later. All right, anything without a given power is thought to the exponent of 1. Anything to the 0 power equals 1. 3 to the 0, 10 to the 0, all these equal 1. If I have an exponent in the denominator, it means that exponent is negative. If I have a root of some sort and a power of some sort, then it's written as a fraction, power over the root. In this case, x to the 5/3. If I've got a rational function with a single denominator, not a binomial, not anything else, a single denominator, a polynomial, which is only a one piece polynomial down here, then I can split it up. 3x squared over 4x would simplify to 3/4 x. 2x over 4x would simplify to 1/2. 1 over 4x would simplify to 1/4 x to the -1. Okay, let's talk about derivative notation for a moment. If fx is the function, then f prime is the derivative. Another way to say that would be derivative with respect to x of f of x. Okay, this is noticed as f prime of x, that's a derivative, and ddx f of x, that's also derivative. This is called derivative with respect to x. This is just called f prime of x. They both mean the same thing. Let's talk about a pattern for a moment. Okay, so if f of x is x squared, I will tell you f prime of x is equal to 2x. If g of x is equal to x cubed, then g prime of x is equal to 3x squared. And if h of x is equal to x to the -4th, then the derivative of h of x with respect to x is -4x to the -5. Before you move any farther on in the video, pause it for a moment and just ask yourself, what is the pattern? All right, so hopefully you paused, and let's check out the general piece of it here. In general, the derivative of any constant, the derivative of a number 5, the derivative of the number 7, the derivative of the number 216 is always 0. Couple reasons why. Why is because f of x is equal to 2 is the same thing as saying y is equal to 2, and any y equals line is a horizontal line. Therefore, the derivative, which means the slope of the original function, the slope of any horizontal line is 0. If you want to look at it analytically, we could write c x to the 0. Remember that x to the 0 power is 1, so this is basically just like saying c times 1. All right, so if I do the power rule, 0 times c, x to the -1 equals 0 over x equals 0. Same thing. Let's take a look at the power rule. This is what I hope you got before. The derivative of x to the n power is n times x to the n minus 1. You bring the power out front times anything out front, the coefficient, and you drop the exponent by 1. The scalar multiple rule says just any scalar multiple comes along for the ride. Any addition or subtraction of functions just means you just take the derivative of its pieces, not a big deal. One to keep an eye on here is the derivative of trig functions. The derivative of sine x is equal to cosine x. The derivative of cosine x is equal to negative sine x. Right? A bunch of examples. Let's go over some and some notation. So if y is equal to 3x to the 6th, I guess I'll do this in another video. We'll stop sharing.